Stoichiometry and reaction rate. For a reaction in which the stoichiometric coefficients are not all 1, we express rate a little differently. For example, 2 moles of reactant A undergo a reaction to form 1 mole of product B. The rate is minus half change in concentration of reactant A over change in time. But in terms of B, rate is change in concentration of B over change in time. The rate expression may be generalized using a general reaction involving A moles of reactant A that react with B moles of reactant B to give C moles of product C and D moles of product D. Essentially, to express rate in terms of each reactant, rate equals negative change in reactant concentration over change in time divided by the reactant's stoichiometric coefficient. If there is a negative sign in a rate expression, it is pointing to the idea that a reactant is consumed rather than produced. Rates are always expressed as positive quantities. To express rate in terms of each product, rate equals change in product concentration over change in time divided by the product's stoichiometric coefficient. In this example, we are to write the rate expression for the following reaction in terms of the disappearance of the reactants and the appearance of the products. To express the rate of the reaction in terms of the change in concentration of a reactant or product with time, we need to use the proper sign, minus or plus, and the reciprocal of the stoichiometric coefficient. Reciprocal of a number means 1 divided by that number. Thus, in the solution shown, the minus sign is only used for the expressions involving the reactants, ammonia and molecular oxygen, not those of the products. In this next example, we are told that at a particular time during the reaction, molecular oxygen is being consumed at the rate of 0.024 molar per second. A. At what rate is N2O5 being formed? B. At what rate is NO2 being consumed? To calculate the rate of formation of N2O5 and disappearance of NO2, we need to express the rate of the reaction in terms of the stoichiometric coefficients. Interpret molecular oxygen is consumed at a rate of 0.024 molar per second. Consumed means that the reactant oxygen concentration becomes smaller over time, so we use minus. Thus, change in concentration of molecular oxygen over change in time is minus 0.024 molar per second. For part A, pull out the relevant terms from the rate expression earlier, linking the term involving O2 and the term involving N2O5. Make delta concentration of N2O5 over delta time the subject of the equation. To do this, multiply both sides by 2, then substitute minus 0.024 molar per second into the equation. We should get a positive value since N2O5 is a product. For part B, again we pull out only the relevant terms from the rate expression earlier, linking the term involving NO2 and the term involving O2. We do something similar by making delta concentration of NO2 over delta time the subject of the equation. Multiply both sides by minus 4. Then substitute negative 0.024 molar per second into delta concentration of oxygen over delta time. We should get a negative value as NO2 is a reactant and it is being consumed.